All right, good morning, everybody. Thanks for having me today. I'm very excited to be here. I'm going to be focusing today on talking about where we're innovating at the edge and what role we play at the edge and delivering unique value. So we believe that the cloud of today is going to need to evolve to meet the needs of what we envision as being, by 2035, as many as 1 trillion intelligent devices and machines connected to the network. And so we think that the technology drivers are going to force a different kind of cloud implementation to meet the latency requirements, meet the power requirements, the compute density requirements. And this is a hallmark of what ARM delivers. And so, again, we think that this new infrastructure that's required to unleash the brilliance of these devices is going to be designed from the edge in. And the edge is going to be heterogeneous. We'll talk about that more later. But we already are being implemented in a lot of the radio access network systems today because of the hardware offload that we do, the power and space density that we have. And then as we see this proliferation of the premise edge, the different sets of cloud tiers back into the data center, again, we believe that this new infrastructure needs to be designed uniquely from the edge in. And we believe that it's going to be heterogeneous. I think most people believe that the edge is going to be heterogeneous. There's going to be CPUs, GPUs, TPUs, NPUs, FPGAs, all of these kinds of workload optimized compute engines are going to be required to deliver the low latency, power, and the space efficiencies. And again, this is a hallmark. This is really what our whole business model is predicated on, building IP blocks so that people can build the SoCs that are workload optimized for different applications. The right combinations of compute, storage, and acceleration into the SoCs. We provide the ability for people to put together the memory controllers, FPGAs, DSPs, TPUs, other things into a single SoC and build that workload optimized CPU, allowing people to create SoCs with up to 256 CPUs, 8 memory channels, all kinds of bandwidth requirements, so on and so forth. And again, the edge is about efficiency, dollar efficiency, power efficiency, and space efficiency. And fundamentally, one of the hallmarks of ARM is the ability to lay down more cores in a physical area on the die. And so we can inherently deliver greater compute density through that and through offload mechanisms that are typically built onto those SoCs. More memory bandwidth and up to 10 times the acceleration. These are real-world examples that we've deployed out into the field. So this delivers incredible value to meet the very low latency, high density, and low power requirements for the edge of the future. Now, one of the big areas that people are talking about, and we've begun to talk about it here at the show, is artificial intelligence and machine learning. And this is going to be a massive focus for ARM moving forward and delivering a great deal of innovation. We're talking about being able to create silicon IP. We're going to be delivering silicon IP that allows for optimized machine learning, neural networks, deep learning algorithms to be implemented both in hardware and software, being able to create these platforms that optimize these training mechanisms, these training engines that create models and then allow you to create these inference frameworks on top of it. And so now certainly machine learning will exist back at the data center in the cloud for different kinds of use cases. But for a lot of what has to happen in this connected world of 1 trillion devices, we're going to need to have machine learning at the edge. And the reasons are pretty obvious. There's no way that we're going to be able to backhaul all of that data back into the core of the network. So we've got to do a lot of analytics, compute, analysis, vectorization at the edge. The power requirements we've talked about, we have to have low power at the edge. And the cost, it's not going to be a simple matter of taking a data center and pushing it out to the edge. I mean, that will solve some problems. It obviously solves some distance-related loss issues and better latency just from that perspective. But it's not just about getting closer physically for the physics aspect. It's also being able to, with these heterogeneous engines, do a lot of that compute at the edge in a more efficient way and do it at a lower cost. The latency requirements, obviously, we've got to get, in some cases, sub 5 milliseconds. Reliability, that goes without saying. And then, of course, again, a big part of our value proposition is security. The notion of a trillion devices connected to the network, we need to establish root of trust right down to the silicon level. So these things the network can be protected as these devices onboard onto the network. So we believe that all of this has to move to the edge in this new connected world. So last year, ARM announced Project Trillium. This is our effort to begin to deliver new intellectual property to the market space, to be able to deliver optimized compute for machine learning, object detection, so forth and so inference engines. And so it starts with our general family of compute processors, the A-class, the M-class microcontrollers, our vectorization instruction sets, the GPUs, the ARM Mali GPU family, and now in the last year, we're delivering neural network processing, object detection processors, and of course there's always partner IP in the mix for other kinds of compute. And what we've done is we've taken, for example, lightweight real-time embedded operating system technologies, the SimSys, that's got neural network capabilities in it. We've created a neural network SDK that's open sourced to give access to these upper level frameworks to all of this new intellectual property. And we've always had the ARM compute library and some of these new object detection libraries that are companion to the IP that we're delivering. And all of this has been integrated with some of the popular applications and frameworks out there for machine learning. So this is now available out there, and you can go and avail yourself of it. Now, I usually talk about the fact that we're always involved in all of the relevant consortia, OPNFE, ONAP, FDIO, DPDK. If we're talking about Edge, I want to specifically, because I'm really driving our membership in Acrano, I want to spend some particular time on that today, but we are in EdgeX Foundry, OpenFog, and other related consortia. But this one in particular provides us an opportunity to work with operators and OEMs to put together very specific blueprints, hardware, software blueprints, and that's our intent for different use cases. And what you see on the screen here are some of the initial use cases that we think we're going to build with our partners. We're going to do a UCP SD-WAN use case. We're going to do an Edge Cloud server use case, IoT gateway, and we've got an operator that wants us to do with them a SIBA reference design, the software-enabled broadband access. So these are going to be really interesting blueprints, and I like what the Acrano organization has done. They've got a very comprehensive plan for creating very well thought out specifications, and then the ability to create these hardware software recipes or blueprints that create a particular platform, and then we can run applications that are relevant to these use cases on that platform. And so we're really excited to get going and start building these blueprints. The specification criteria and documentation will be complete next week, or actually today, October 9th. And so based on that, we can go and actually submit our blueprints. And so you'll start to see those coming from us and our partners. We're very excited. And as part of that, we plan to work with some of our partners and our ecosystem members and our engineers, we have proposed a lightweight edge reference stack. This is what it looks like. It's pretty roughly sketched out right now. There's some optional pieces in here. But we feel like for the different use cases, we're going to have different combinations of these building blocks. We're going to put this together and then integrate it in with the rest of the planned pieces, ONAP orchestration, edge APIs that are being developed in Acrano, and other key pieces for telemetrics and so forth to build these edge solutions. So we're really excited about that. But part of what I always do at these events is we have an ARM ecosystem zone and an edge innovation zone in the main hallway near the entrance. And I like to talk about proof points that our ecosystem is developing to show really what the value, the TCO value proposition of ARM-based solutions. One of the ones that we're showing here in The Hague this week is a reference design, a really out-of-the-box box, pretty incredible, a kind of an edge compute ML storage reference design from a consultant that we're working with, Cash and Go. And this is the way that they sort of describe the storage solution here and the edge, this sort of edge architecture is, you've got your traditional, sort of rack of servers, and you could just push that right out to the edge, and that could be your edge solution. But again, for the workloads that we're seeing, for the efficiency, the low latency, the power, the space efficiency, that's not going to be enough. And so we need something more innovative, or else we're going to have a major challenge in terms of cost and power to be able to deploy these systems. So what these folks have done is they have created a reference design that's essentially a grid of compute, machine learning technology and libraries, storage and networking on very small, grid of very small Pine 64 boards. These are quad processor. Each processor is quad core with 2 Mali GPUs. And they've created a grid of these, and they put it in a standard package, an OCP package or a standard 19-inch rack model. And you essentially can collapse multiple, an entire rack into a box. We're talking about the ability to put, something on the order of 384 processors in this single box. And when you add that up in a rack, you've got 4,000 compute nodes in a standard rack. And what you end up with is a compute density that's 95x, a power reduction that's 15x, and a CapEx savings of 10x. And this is a really interesting system that's getting a lot of interest out with the operators in the community for lots of different use cases. You see some of the use cases listed here. But again, the idea is to really think outside the box and leverage low power, high density, low cost compute engines that are suitable for a lot of edge workloads. And there's a lot you can do with this, with ARM Compute Library, with the GPU technology, and later on with ML IP to do a lot of edge applications right here on this box. So that's very exciting. So please come by our booth and see that. Another one that we're showing here in The Hague is from our friends at Telco Systems. So again, one of the clear edge use cases is a universal CPE and an SD-WAN related. So we've got systems built by Telco Systems with multiple silicon solutions, multiple SoC, ARM-based SoCs in the box, multiple white box partners, and then a number of the VNF vendors that are common in these solutions on this package. And Telco Systems does their own NFVI based on OPNFV. They add their own Mano and their zero-touch provisioning. They take full advantage of the hardware offload of some of these processors, and of course they take advantage of the ARM Trust Zone security that's built in. And so lots of different choices and a great TCO advantage. And so when we talk about, well, so why would you care what's in the box? Well, in the end, we end up delivering better raw performance as compared to similar options that you might deploy with. Better performance per cost, better performance per area, per watt, the security aspects, and programmable hardware offload. And just to give you an idea of some of the impact of that, if we compare to a low-end comparable popular architecture for a quad-core part, we've got an octal ARM part, and we do offload of Open vSwitch. And that Open vSwitch is known for taking a lot of system resources. Now, for this part, for the same power envelope, for the same cost, we get 2 times the raw performance. We get 7x the performance per watt and the performance per dollar. So again, this is a really concrete example of how the fundamental compute density story from ARM combined with hardware offload, low power, gets you more with less. So I want you to visit us in the main expo area, and we've got this ARM ecosystem zone there. We've got a couple of other partners. NIA Software is showing a service function chaining solution that they have in the booth, and we also got our friends from Quartus showing an innovative CUPS compliant MEC EPC running that can run on something as small as an Odroid ARM, really low power and cheap ARM SoC. So what I've tried to convey to you today is that ARM is very focused on the edge, and we're delivering unique technology in terms of IP. We're delivering compute density, power efficiency, price efficiency for an unmatched TCO at the network edge. And we're involved in all of the relevant open source consortia because we believe that this is the way to really drive innovation. And in those consortia, we're driving multi-architecture support and bringing our unique value proposition to demonstrate these use cases on these really efficient platforms. And the ARM ecosystem, as you can see here, is building the unique and compelling proof points that show you the kinds of TCO advantages that the ARM ecosystem delivers to the industry. So we're very excited about the future and delivering on what is required for the edge. Thank you very much.